Okay, let us continue. So what we found is that Cv as a function of t can now be written according to Debye as 9nk t by theta d whole cube, and then 0 to theta d by t x to the power 4 e to the power minus x divided by 1 minus e to the power minus x whole square dx. Now, as we were saying, that this can also be written as something like t by theta d whole cube and 0 to theta d by t x to the power 4 e to the power plus x divided by e to the power x minus 1 whole square dx. So they are equivalent. Okay, that can be seen that suppose you take e to the power minus x common from the denominator, it becomes e to the power minus 2x, and then 1 e to the power minus x gets cancelled, and that can be written as e to the power x. So it is same. Now this, for convenience, this Debye result can be made written like this as 3nk and then a Debye function which is a function of t by theta d like this. So what is Debye function? So Debye function is referred as, say, d of y. It is the Debye function, and 3 is here, so 3 into 3, that becomes 9, the same thing, and then it becomes dy cube, 3 into y cube into 0 to 1 by y x to the power 4 e to the power x by e to the power x minus 1 whole square dx. So if we now consider, so this becomes actually the Debye result, okay, for Cv in terms of Debye function, which is defined here this way. Okay, now let us see the two cases. So first one is the high temperature limit. High temperature limit, okay, that means t tending to infinity. That essentially means t is much greater than the characteristic temperature, in this case that is the Debye temperature, right? So given this, what is dy in this case, that argument y is tending to 0. So Debye function will have that. Essentially what we have to find is when temperature is very large, that means this coefficient is very large, this part is constant. So what is the question ultimately turns out to be dy when y tends to infinity, right? What is this? That is the question. Now if we just substitute it, this becomes 3y cube and then 0 to y x to the power 4 e to the power x by e to the power x minus 1 whole square dx. Now you see that, sorry, it is not y, it is 1 by y, right? So limit is 1 by y. So you see, in the limit is 1 by y, so when y tends to infinity, this becomes basically very small number, right? So the upper limit of the integration becomes very small number. That means all these x values are very small. Once x values are very small, this denominator can be expanded as, so like before, that e to the power x limit x tending to 0 can be written as 1 minus x. So it becomes 1 minus x minus 1. So 1 gets, e to the power x becomes 1 plus x. So 1 plus x minus 1, that becomes x. So x square, then 1 x square gets cancelled out. So it becomes x square e to the power x. And when x is very small, and you have only to compare with a value of 1, right? So that becomes again e to the power x can be then put as 1. So effectively it becomes, this integral turns out to be that 0 to 1 by y x squared dx, and that turns out to be equals to x cube by 3. So 1/3 x cube means 1 by y cube, the limit. Okay, now if we substitute it back here, so this part actually becomes 1/3 y cube. So dy, so what we find is that as limit y tending to infinity dy goes as 1, right? Because 3y cube and this is 1/3 y cube, 1 by y cube, so that becomes 1. So this function becomes 1, dy function goes to 1, and then in that case CVT goes to 3nk. That is the upper temperature, high temperature limit, right? So that is the high temperature limit, and that for a mole of for 1 mole of a crystal, and then it becomes n becomes Avogadro number, so it becomes 3R. So they are giving the same result as that which was also obtained in Einstein's case, as well as that is the prediction of Dulong-Petit law. So it is nice, it can explain the high temperature limit. Now let us go to the low temperature limit where Einstein's result failed. So low temperature limit we have to analyze, and that is temperature tending to 0, and that essentially means temperature is much less than theta d. In that region, what happens? Now for that, what we can see is that for that range of temperature, what we again have to do is essentially finding out this dy function, and dy function part has got, as we said, 3y and this. So when t tending to 0, essentially what we need is Cv in that temperature domain is 3nk into you can say limit t tending to 0 is limit, say how do I put it? So say y tending to 0 and d of y. So dy function at y tending to 0 we have to find. So let us see. So dy function, when let us get back to the dy function expression, and here y tending to 0 means the upper limit of the integration becomes infinity. So essentially what we have to find out, 0 to infinity, this kind of integral, x to the power 4 e to the power x divided by e to the power x minus 1 whole square dx, and this turns out to be a standard integral, and its value is 4 pi to the power 4 by 15. So this is a known constant value result. So let us put this part in the dy function under the limit of y tending to 0. So in that case this becomes 3nk, and then from dy function you have a 3y cube that remains, so 3y cube, and y, y is in this case t by theta d, right? So that is 3, and y cube becomes that coefficient, that is t by theta d cube. So t by theta d cube, and then you have 4 pi to the power 4 by 15 coming because of this integration. So if we just collect all of them together, then it becomes how much? It becomes 9, and then 3, it again gets 5, so 12 by 5, right? So 12 by 5, and then you have pi to the power 4, and then you have nk, and then you have t by theta d whole cube. So this actually turns out to be CVT is proportional to t cube. So this is the result that we are looking for, which explains the nature of temperature dependence of Cv in the lower temperature domain, lower temperature range, and that is why Debye's analysis, that is considering the short wavelength frequencies arising because of the normal modes of vibration within the crystal, that could explain the d by t cube law, and that is why